Good afternoon or good morning to everyone who's joining today. Really excited to welcome you for this geothermal webinar with fantastic speakers. So welcome. We're very happy together with Marble and Underground Ventures to introduce this webinar. I'm going to give you a quick introduction. So Marble is one of the two co-hosts of this webinar. We are what's called a venture studio, which means we partner with scientists, engineers, and operators to create multiple companies in parallel that solve hard climate problems. So importantly, we're not a fund, so we're not looking for companies in which to invest. We create new companies. We're not a startup accelerator either, because we create the companies. We come at the origination. So we are a studio. We create multiple companies in parallel. We have built 9 companies since we started at the end of 2021 in various sectors, 10 actually, because there's a new one on enteric methane that we're spinning out right now, but we've worked across sectors like geologic hydrogen, ammonia, concrete, DAC, and many more. We are very interested in geothermal, which is why we are speaking today. Broadly speaking, the way we work is we look for very interesting problems to solve. So we recently published an article called 25 Climate Opportunities, where you can find some of them. Geothermal is high on this list. And we try to build conviction for each of these problems and sectors of why this is a massive opportunity, what are the technical white space we're after, what are the type of founders we would like to hear from to build great companies with us. And these individuals join us before they have a company, before they have a team, before they have a specific idea, even sometimes. And we work together with them to help them find the best idea, generating multiple ideas, killing the ones that are the less interesting and progressing the best ones, and then helping them turning these ideas into a new company. And then we help them build a company. We invest at incorporation, $250,000 per company, and we work with the founders to help them achieve their milestones and raise the next round of financing after. All right, so I'm very excited to co-host this webinar. We're going to start with our first speaker, Rebecca Schulz, who's a senior analyst at the International Energy Agency and who was the co-author of the recent geothermal report that the IEA put together. So Becky, I'm going to stop sharing and let you share, and let's go.
Thanks so much, and thanks for the opportunity to join you all today. I'm going to share my screen, and along with that, share some of the output from a report that we had released last December that was requested by the Hungarian presidency, or the Hungarian EU presidency. So I'm presenting this report on behalf of a number of different authors and also a number of organizations and companies that helped us to pull this together. And this report took a look at essentially where geothermal sits today. And that's largely actually in heat, in geothermal heat pumps, but also in district heat as well. The amount and a large focus of the report that we had presented out in December takes a deeper look into electricity and power generation potential for geothermal, but it really spans across all of the different types. And I think Ingrid is going to deepen the discussion on heat a little bit in a few minutes as well. When we look at electricity and power generation in general, geothermal actually only represents much less than 1% of electricity generation today. And even in our announced pledges scenario, which is our scenario as part of the World Energy Outlook, that looks at what, following the COP26 program, what if all of the companies or all the countries had actually put together their pledges and enacted those pledges? Where would that take us with respect to carbon emission reduction, and where would that take us with respect to clean technology proliferation across the energy sectors? And in that scenario, it really only reaches about 0.8, less than 1% by 2050. Geothermal energy, along with heat, district heating, and heat pumps, there are a few major categories of geothermal that we talk about today that have really started to progress. Some, like conventional hydrothermal, have been in place for well over 100 years, but others, like enhanced geothermal systems, that the type of technologies that FERVO is using today, really stem out of technology innovations out of the national labs in the US, starting really in the 1970s. And then more recently into these type of closed loop systems, where there, in the case of error, for example, there are wells that are drilled from different locations on the surface and then connected in the subsurface. And each of these different types of geothermal also relies on different aspects of energy and heat exchange as well. So the technology innovation can really potentially unlock geothermal where these new technology innovations, so EGS and these closed loop systems, also there's a number of different acronyms out there on the market for them, can really help to unlock geothermal where conventional hydrothermal systems do not currently exist. And when we look at that, so a shout out to Project Interspace that helped the IA in the report to really understand what is the subsurface geothermal potential that exists out there. And so this shows a shading of essentially with the darker red color showing areas of higher heat generation potential and where that exists globally. And so when you see areas of deeper red, those are sitting along the plate tectonics in areas where we typically have more conventional geothermal exploitation. But really the potential for geothermal truly is anywhere, but it's dependent on a few key factors and key pieces of success as we go forward. Some of the technology breakthroughs really have to leverage the oil and gas industry in order to be able to unlock that potential. And so geothermal, to really be able to scale up, needs to be able to be drilled down, nearing down to 10 kilometers. The next generation geothermal technical potential has the potential to upscale up to 60 times more than today's power capacity. The full potential, if we truly unlock all of the learnings that we have across oil and gas, but also across all those other sectors, we can double that potential, more than double that potential, up to 140 times. And I apologize, I'm going through these a little bit quickly. I want to give you a bit of a teaser for the report itself that you can find online by Google or bigging IA geothermal. But we wanted to touch on the oil and gas sector itself and the role that it could play with respect to transferring technology across to, in this example, enhanced geothermal systems. So with enhanced geothermal systems, wells are drilled from separate places on the surface, typically fracked or hydraulic fracked, like it's done in unconventional shale development. And then fluids are pumped through, typically water pumped through from one location and then produced from another location. And as the fluids are in the subsurface, they pick up the heat, travel across through those fractures, and then are produced by another. In this case, we're showing the cost reductions from a 2023 baseline. And for within that, if we just take essentially like what the oil and gas technology could very easily, very quickly move across, what we call low level of transfer, we drop that cost basis by just a little bit. If we deepen, though, the areas of technology, the base scale research, that research done on the benchtop, but also build up the economies of scale. So essentially working to do things in a more modular fashion than the conventional hydrothermal industry has done typically. And take a look at what type of technology spillover, which is things that we do in the oil and gas industry that are really similar to geothermal. What happens if we essentially pick those up, transfer those across effectively? What type of learnings can that transfer across? And what is the cost savings implication of that? And so at the higher level of learnings transfer, we can really drive down the cost of enhanced geothermal systems. And that's what companies like Fervo and Sage and others are out there trying to do today. And with that, we see the potential for more than a 3/4 savings from the costs that we saw from a baseline in 2023. And what this does, it opens up huge potential for geothermal power. And so it's taking the high transfer of skills. We see about 80% of skills that exist in the oil and gas industry can be transferred across to geothermal. And with that, we can really drive down the cost of geothermal. With the extra advantage that geothermal itself can run 24/7, unlike other technologies, and also can be, with care, ramped up and down. And so there's an element of both it being dispatchable, with it also being deployable, potentially nearly everywhere. And then also, though, it really depends on the ability to transfer learnings from the oil and gas sector and moving that across. I'm going to end there. I'm trying to keep to a 5-minute time frame within that. So it's a very, very, very quick overview. So apologies for that. But perhaps I can hand it back over to you.
That's fantastic. Thank you, Becky, for being very concise and for this great presentation. I think that leaves us more time for the Q&A after. So everyone, by the way, we are going to have the Q&A after the 3 presentations. I think it's really important for everyone to appreciate how meaningful it is to have an institution like the IEA fully endorsing geothermal and its potential. And so that was really great to have you summarizing the key highlights from the report, Becky. Thank you for that. We're going to move to the second co-host of this event, Underground Ventures, with Torsten, who's been investing at the early stage in the space and has a lot of learnings and insights to share about his work in geothermal so far. So Torsten, the floor is yours.
Thank you. And thank you, Rebecca, for an excellent intro. So now that you all have an intro to geothermal, I can tell you a little bit about how it is to be in venture capital in geothermal. And here, of course, I know we have a little bit of a mixed audience today. There are some of you that are very well versed in everything that's happening, and some of you that are fairly new to it. We're going to try to strike a balance a little bit in the middle here. Let's start off with a quick intro to Underground Ventures. We are the world's first specialized geothermal venture tech firm. And that is a little bit of a crazy endeavor because that's extremely specific and in some ways also very concentration of risk that in venture capital is not always wise, but we're going to take a crack at it. We started a year and a half ago and have done the first 4 investments, which you see out here on the right. And what you can see is that we've done investments in what I would call sort of the picks and shovels of the industry. So the types of companies, startups that are helping geothermal developers lower costs and risk and get us closer to that scenario that Rebecca showed in the intro of how technology and learnings and repetition is getting us to possibly the cheapest form of energy that we can find in the future, which is really cool. So that's what we set out to do. And I think we've learned a bunch of things from talking to a lot of other investors and diving into the market of investments here. And so I thought it would be interesting to share a little bit of those learnings, because it's actually very hard to find good data on geothermal, both venture and non-venture investments. It's still very niche. Here is some data that we'll go over in detail in June at an event in Houston with Geothermal Rising called Geothermal Investment Forum, I think. So this is just a couple of slides from what those of you going to that will see. But what you can see here is that over the past 7 years, we have seen a dramatic increase of funding into this space. We went from pretty much nothing to well over $1 billion last year in investments. And equity, as in venture capital, is the blue part of these charts. That is the predominant source. But I think it's really interesting and very good and healthy to see that there's a number of other types of capital flowing into this space, including loans or debt, grants, governments, and others, and project financing going into this. For those of you that know the industry, Rebecca mentioned Fervo and Ever, 2 big companies in the space. They certainly are the primary drivers of capital into this at the moment. There are actually quite a large number of companies in this space. Now, if we look at where the money is coming from, that also was, I'd say, fairly surprising to myself and our little team, in that what you see here on the left is the number of investors by type. So you can see we have 84 venture capital firms that have done 1 or more investments into geothermal. And before diving into this data set, I would have probably guessed 25. So it's an enormous amount of investors. But what I also really like to see is that we have a lot of other types of entities that are investing here. We have corporate venture capital, we have strategic corporations investing, we have family office or high net worth individuals making their own decisions, governments mostly doing grants, but not exclusively, and more sort of traditional banks. So everyone is in on the game here, all in the past 5 to 7 years. On the right, you see essentially the same chart, but now you see it by millions of dollars invested. And I think the only thing that's interesting here is that when corporate goes in, they go in big. And that's why you can see corporate VC and corporate strategic are really the big hitters and punch above their weights here in terms of investments. But I most of all just like that there's a lot of them and that it's very different types of capital, not just venture capital, but a lot of other types of funding. Then asked me if I could share just the name of a few startups that I like in the space. I showed you, of course, the 4 that we have invested into, which of course are my favorites, obviously. But those aside, there are some other cool things happening in the space. I think some of you may have heard of these companies. Eden is developing reservoirs in the subsurface, but with the use of electrical currents. Quite a cool way to open up a reservoir where you can flow water through in the subsurface. And maybe for those of you that are not fully aware of the basics of how these systems work, you have typically 2 wells into the ground. You inject water in on one side and you are producing hot water or steam of the other side. And then you essentially are cycling that. You have a loop where your hot water or steam gets cooled down and gets re-injected. So you essentially just are sort of producing free energy constantly 24/7, which is quite nice. But in order to do that, you are going to need a reservoir in the subsurface. And if that's not there naturally, like in Iceland where I am, where we have it everywhere, you're going to have to develop that by either drilling it like Ever does, or by fracturing the rock like Fervo does, or other methods. So Eden is interesting. XGS is kind of a cool company on the west coast of the US. They have developed a single well design where they can extract more heat out of the surrounding rock without having to opening a reservoir. And that's really interesting because what we look for a lot here is modularity. We love to see when companies go about solutions that are globally applicable and very simple. So even though they have a while to go, these are all startups, definitely a cool design. And then the last one I wanted to add is Terraferno, just as an example of somebody who is solving a very specific problem. And I'm not here to like get everyone to be geothermal technology experts necessarily, but I think this is a good feel for the types of problems that we need to solve. So when you have a reservoir, let's say Fervo has developed, and you have you've fractured the rock and opened a reservoir where you can flow water through. The problem is that all these fractures can actually be quite distributed. You don't know exactly how your water is going to flow. So having devices or systems that allow you accurate flow control from your injector well to your producer well in a way that maximizes the exposure to the surface of the rock really dramatically improves the performance of your system. What you're trying to do is to pump water down at, let's say, 1520 C and get it up as 200 C, very hot, high pressure steam. That's the ideal system. But if you don't do your flow control well, you might get just lukewarm water up the other well. And so it really can make a big difference to how your system performs. So this is the sort of stuff that startups come to the rescue and help these companies fix and improve their performance so that we can really scale this up. And then the last thing I want to slide before Benjamin cuts me off is a little bit about what I would call the mismatch between where money is going and what actually are the technology gaps that we need to fix in order to be able to scale this up. And so if we start on the right here, you can see that most of the funds going in are going into different types of developers, providers, people that are out there drilling, developing reservoirs, either just geothermal or other types of entities. Just ignore those for a moment. Further down on the list, you have the more technology-specific companies. So these are companies, for instance, building high-performance drilling systems or figuring out how to convert power more efficiently, steam to power. And those are receiving very little of that, couple of billion of dollars that have been invested so far. So now compare that to what we have on the left, which is a mix of the Clean Air Task Force technology gap reports, which I can also recommend, by the way. Just Google CATF geothermal, and you'll find a bunch of really good resources. A mix of their reports and Underground Ventures internal assessments of what we think are the most likely problems we need to solve. And what you can see here is that there is a little bit of overlap, but we have, nothing that's in the developer provider side. We're happy it's happening, but that's not really in the technology gap section. But we do have things that are actually not even being invested in today. You can see something like well casing and completion. And this is the discipline of what you have drilled. What do you do to make sure your well becomes production ready? So it needs to be really, typically you lower steel tubes in, you cement them in place. You need this to be able to work for 50 years and at high temperatures and pressures. So going from a well bore that you just drilled to a production ready well is really a difficult discipline. It's very expensive, and we're relying on oil and gas technology. And we would love to see some new developments and technologies that would, if we can up that efficiency, we would win a lot. One of the ways to do that is by having a higher temperature in our well, but there's a bunch of other things you could do there. Power conversion. And then maybe the last thing I'll mention is the modularization. So how do we make this look as much like wind and solar as we possibly can? The reason why wind and solar went down in price and up in scale was mass manufacturing, mass distribution, mass deployment. And so if geothermal is considered this like, geography or geology specific deployments that have each their own risk and need to be assessed in their own way, we will never get there. So we have to develop technologies that are just globally applicable and standardized. So a good old-fashioned bank can look at it and say, great, please take my money. I trust it'll work. And that, I think, is a discipline all of its own. So maybe let me pause there, and we can always get into discussion later after Ingrid goes.
Thank you, Torsten. It was a great presentation. I have so many questions, but I will save them for the Q&A. And I can see, by the way, that audience questions are starting to pile up. So please don't forget that at the bottom of your screen, you have the Q&A button to start asking questions, and we'll curate just after. All right, let's move on to our third speaker, my colleague Ingrid, who's been looking at geothermal quite a lot. Ingrid, the floor is yours.
Perfect. Thanks so much, Ben. And I will also have a bit of overlap, so that makes my presentation even quicker, which is great, which means we move on to Q&A very quickly. And yeah, I'm just going to give a quick overview on venture creation in next-gen geothermal today. So a lot was spoken about power. We know that electricity is going to triple by 2050. Rebecca highlighted this as well in her presentation, but heat as well makes about 50% of global final energy consumption, and geothermal is uniquely positioned to be able to provide a low carbon energy source for both heat and power. And if we start with geothermal power, which is a clean and abundant and reliable source, it has failed to meet its potential so far, but the potential, if we tap into next-gen geothermal, we're looking at a 50-fold, more than 50-fold growth by 2050. And in order to achieve that, we're going to need a lot of innovation. And Rebecca and Torsten also touched on that. What does the competitive landscape look like today? There's a lot happening in drilling technologies, as well in terms of other subsurface technologies. So the type of electronics that we use, trying to reach even higher temperatures, working on closed loop designs, working on stimulation for enhanced geothermal services, but also looking at the power plant itself and technologies to increase the efficiency, try to down cost the power plant, because it makes up quite a significant chunk of the levelized cost of electricity when we try to produce electricity from geothermal power. And when we talk about power plants for geothermal, we're usually talking about the organic Rankine cycle. And we see a lot of innovations happening there, trying to increase the temperatures for the working fluids and trying to improve on efficiency there. But if a lot is already happening, where are the opportunities for venture creation? And I think, as we have seen already, and as we're going to talk about as well, there's a lot more opportunity for the future. And especially when we want to talk about drilling deeper, going for higher temperatures, yes, we improve on drilling, but there's still a lot that can be done. We need higher rates of penetration. We need measuring and logging tools that can work with the drilling to be able to handle even higher temperatures. As well, what Torsten touched on in terms of well completion, which isn't talked about enough. We need new cement materials, casing materials, all about being able to handle such extreme conditions that we haven't been able to access before. And another thing is that when you have your well casing, you have your connectors, and they are a weakness. And so in terms of maintaining well integrity, that is something that doesn't get enough attention so far. Also, when we talk about enhanced and advanced geothermal systems, we need to look at novel stimulation techniques, novel materials, all of these things. There's still a lot of room, and this is just in the subsurface. So then we can also look at the surface, we can look at the power plant, turbo machinery. If we're going to access higher temperatures, that means we need to look at new thermodynamic cycles, potentially new working fluids, also how we construct the power plant, being more modular, trying to utilize more prefabricated components, and also looking beyond the turbo machinery itself, beyond the turbine. Heat exchangers don't get enough attention sometimes, and how do we just optimize operations so that efficiency is as high as possible? Because in general, when we're talking about these lower enthalpy conditions, efficiencies tend to be low. So we need to try to maximize that as much as possible. And the silent giant, which I think is well named here because it doesn't get as much attention, is geothermal heat, where also the potential is massive for the future. And if we want to talk about geothermal heat, then we can bucket it into 3 end-use cases, which is building scale, so residential, commercial buildings, district heating networks, and industrial process heat. And geothermal is well situated to be able to satisfy heat demand up to about 200 degrees Celsius, which isn't something negligible because about 50% of global heat demand is below 200 degrees. So how does the innovation landscape look for geothermal heat? We can see that when it comes to ground source heat pumps, wells that satisfy residential and commercial buildings, we have quite a lot of companies looking at it. And that's also because historically ground source heat pumps have been the way to go. So you have a lot of companies that work on the heat pump, work on improving drilling so that you install the well faster. But you also have now more interest in district heating networks, as well as repurposing old natural gas pipelines to convert them to geothermal district heating networks, such as what Eversource and Heat do. But also there's the avenue of looking at providing process heat for industrial applications. And you see there that there's not as much attention being given to that avenue yet, because it's hard as well when you try to go for these higher temperatures. There's a lot more room to play, I would say. And that's why, as well, the space for venture creation is also big for geothermal heat. One thing is because the upfront costs are so high. Looking at accelerated drilling and installation, how can we facilitate that to minimize upfront costs, minimize the installation time so it's easier on the consumer is a big question. Additionally, utilizing things like thermal modeling and demand response. Demand response is very important when we talk about district heating networks, because you're going to have different heat loads. And how do you respond to that in the most optimal way is a question that's being asked now. And also looking at novel working fluids and materials. And that's especially relevant when we want to maximize heat recovery from our wells, but also if we want to push the limits beyond 200 degrees Celsius. And so that's why for us at Marble, geothermal plays a big role in our interests. We're very interested in building companies. We think the potential is massive, like we've been saying during this webinar. And we think a founder potential, someone with high founder potential has a strong technical background, industrial experience, entrepreneurial drive. And some of the profiles that we look at, obviously there's a lot of overlap between geothermal heat and geothermal power. But obviously with geothermal power, you look at deep drilling expertise, materials experience in extreme conditions, for example, turbomachinery if we're working on the power plant. But also with geothermal heat, then it's more about the heat transfer, thermal systems, also subsurface drilling as well. This is just an example, definitely not an exhaustive list. But if anyone is interested in joining us for the geothermal renaissance, please do not hesitate to contact us.
Thank you, Ingrid. And thank you, all of you, for these great presentations. Excellent. We have about half an hour left for the Q&A. We have many audience questions and a few we have prepared as well. So let's get started with geothermal power, maybe as a start. So one other thing I've observed is you have very strong opinion in the community whether we should get started immediately by going all the way to super deep geothermal, because that's the big unlock for very high enthalpy, very high power density geothermal. And then you have maybe another camp who's more like, hey, maybe we should go more incremental and like take advantage of the resource we can access more easily, and then make our way to super deep. And I'd love to get your quick opinion, the three of you, of what do you think is the best approach for the field? Yes, Torsten?
Yeah, I'm happy to take a crack at it first. I don't think it's either or. I think it's both, and it's only a matter of the timing. And I think we often forget to talk about how much geothermal today is reliant on oil and gas experience and technologies developed over 50, 60, 70 years of time. And so when we are operating at, let's say, 200 C, 180 to 200 C today, like Fervo and Ever and pretty much everyone else is, it's because that's where oil and gas technology usually caps out. So the minute you're moving to super hot rock, which I agree would be amazing, you are now in a territory where you have to innovate on almost all aspects. You're going to need better casing, you're going to need better drilling, you'll need, possibly new power conversion. You might, need sensors that are more heat resistant, flow control, and so forth. So it just is, by definition, a big step to go from 200 C to, let's say, 400 C. However, the upside is also massive. And I think the most important principle to convey here is that it's not just that your steam is bringing up a lot more energy at 400 C than it does at 200. I think most people would fairly easily understand that. But the power conversion efficiency, when I mentioned, the 15-20% before, if you are doing that at 400 C, you might be getting 50% power conversion in a direct steam turbine, which combined with extracting more heat per mass of water in the same well, you can get 5 to 10 times as much electricity by changing nothing other than the temperature from 200 to 400 C. So yes, it's a big leap, but it's absolutely worth it. Should we wait with 200 C developments to make that work? No, absolutely not. We should absolutely do both, but expect long term that 400 C is probably what you will see in most places, very long term. That would be my guess.
Thanks, Torsten.
Oh, sorry. Go ahead, Ben.
No, go ahead.
I was gonna jump in with Torsten and fully support your views on that. I would say though, with everything that we know today and can enact on today, I would say the push into heat is the really easy win, because the technologies, essentially the technologies are reduced. The need is heavy and it's there. One of the key reasons why it hasn't moved across is because as Ingrid was showing, where a lot of the applications and a lot of the sectors are in district heating and in buildings, and there you typically have a principal agent problem where the owner of the building is not the person that is living or leasing in the building and not the person necessarily that's paying for the renovation or vice versa. And so it's more of actually of a policy issue to tackle rather than a technical issue to tackle on that one. And a lot of we haven't talked much on the social acceptance, and it's come up in a lot of the questions that we've got in the Q&A, but the social acceptance piece of geothermal, if we start to move towards drilling wells or fracking, is still a tough one to crack. And so I fully agree with Torsten that it's both, or all three, or all four, or all 10, because quite frankly, the innovation across different sectors and really, I think, coming to the forefront of what the subsurface can provide for us, whether it's geothermal lithium or other brine extraction, whether it's heat, whether it's super deep hot rock. The innovation is ongoing, and I think that's really exciting. But if I were to pick one, just to say go do it today, the easy win for me is heat.
Thanks, Vicky.
Can I add? Yeah, just very quickly, I completely agree with what both of you said. I'm a massive supporter for definitely go for heat. And I would say that in line with everything that's been said, we need to walk before we can run. And I think sometimes if we just run straight towards super hot rock geothermal, there's going to be so many failures along the way and will make ventures much riskier. So if we go for the heat and the shallower depths for electricity, while keeping in mind that we are developing these technologies so that they can work for super hot rock, so that they can handle the higher temperatures, we're developing the well casings, we're developing all of these technologies, then the ultimate goal is to hit the super hot rock and get to these massive scale-ups in geothermal power, essentially.
Great. Thanks a lot, three of you. There's a lot of questions, and I know we've covered that already in the chat, but around what's the biggest unlocks for subsurface technologies to down cost geothermal power. So I know several of you have covered that already, but if you had to pick maybe one or two things where you think founders should be working on that seems the most the highest leverage to you, what would it be?
Can I start?
Yes, you can.
So I think drilling is definitely important, but I think drilling gets most of the attention. And yes, it's a massive part for downcosting the big, massive geothermal project. But I think there's a lot that needs to go along with it because all of these technologies are going to be working hand in hand. So for me, it's all about developing the materials that are going to allow for well integrity and an increased well lifetime at these super high temperatures. And I think this is something that hasn't been cracked yet. So for me, this is where we need to be focusing more attention.
Great.
Yeah.
Torsten?
Yes. I I think it might be, there's no good answer for this, first of all, Ben. I think it might be wise to look at where the money is going. If you're developing a geothermal, utility scale geothermal system, you're actually likely seeing about half the cost being subsurface and the other half being surface. You're looking at your turbines or ORCs, cooling tower, connection to the grid. That whole surface piece is actually a big chunk. So in terms of where is the big unlock, well, we kind of need to bring down costs both on the subsurface part and the surface part. And the subsurface part, yes, drilling is a massive driver, absolutely. I think casing will be later, possibly reservoirs, but right now drilling it gets a lot of attention. I agree absolutely with Ingrid on that. And it is being solved by some really cool companies. So I feel good about that. But I think the surface part and the general modularity aspect of it, both in subsurface and surface, I think you can interpret in a lot of different ways as a founder.
Maybe I can follow on from Torsten, because I think that's and Ingrid, I think both made really, really great points. Adding on to that, when it comes to the surface side, I fully agree that I think Ormat's been doing a really good job at trying to modularize their work and putting that out. But a lot of this technology and a lot of this trialing is not necessarily new, right? I mean, it's been since 1970s and 80s, and more recently in Australia and elsewhere, even here in Europe and Switzerland and France. But I'd have to say the ability, and I know that these companies can go out and drill it, and I know that they can go out and complete these wells. But what we haven't really established across the decades of geothermal is the ability to keep these projects up and running at the capacities that we've spec them at for not just 5 years or 10, but 10, 15, 20 years onwards. And so for me, it's really getting out there and trialing and ensuring that we know how and can demonstrate that we can actually produce these in the long term and do that sustainably. And so what are the production technologies, the production systems, and the use of, and I think a lot of cases, some crossover from AI and that sector could be really beneficial to where geothermal has been at over the last few years.
Great. And because all of you mentioned power conversion technologies and surface technologies, there's actually a question in the chat as well around are basically existing ORC turbines and systems sufficient to do the job? What exactly is the gap here?
I take that one. Yes, a lot of people have worked on these systems for a long time, and physics, of course, have some limitations. But I think there are a couple of things that you can think of. The first thing is that when you develop a new, and again, we're back to utility scale geothermal here. I totally agree with Rebecca on the heat opportunity and heat pumps and everything else. I love it. We invested in core robotics in that space. However, if you are building a big utility-sized system, you are likely to see a little bit of typically a decline, or at least a variation in the performance of that system over the first 1 month, 3 months, 6 months of time until it stabilizes. So it's actually quite hard to predict exactly what your production is going to be from that reservoir and system that you created. So if you go out and you buy a very expensive turbine, let's say $10 million unit that is being dimensioned exactly for you, those things come with a very specific performance window where they're within exactly this temperature. 175 to 185 is where they're really good. So if your reservoir ends up moving out of that temperature frame, you might be stuck with either a sub-performing system for 30 years, 50, or buying a whole new turbine. And so this is an industry that has never had to innovate the way, let's say, Tesla has thought about, building batteries and cars. They are bespoke. They're building these things made to order. This is not mass production, very expensive systems. And that even if the physics are the same, you can still fix a lot by rethinking how a power conversion happens in these systems at scale.
Super cool. Thanks, Torsten. I have another question in the chat that's a little provocative, which is, do you see any chance that closed loop systems will ever make sense? Which I assume means it's expensive today. Do you see that ever making sense economically?
Is this one me again? Does anyone want to take this?
If anyone who wants to pick this.
I don't know. Ingrid, I don't know if you're about to take it, by all means. Otherwise, I have an opinion. I'm happy to share.
I was going to say it really depends. Is it prohibitively more expensive now compared to other options? Yes. Is there potential to try to down cost closed loop systems with innovations in materials? Potentially, I would say. I'm really trying to give as correct of an answer as possible. I think also we need to consider the regions. So for example, here in Europe, there are more barriers to overcome with EGS as well because of permitting and regulations. So for example, what happened in Switzerland with the operations being shut down because of a lot of fears of seismicity. So a lot of people here in Europe are talking more about closed loop systems just because of those kinds of challenges. So I think that is something also to consider. And also when it comes to shallower applications, then yes, closed loop becomes even more interesting as an option.
Thanks, Ingrid. Well put.
Yeah,
Torsten?
absolutely. I think the only thing I can add to that is that it's complicated because you can fracture a reservoir in different ways. I showed you Eden before. That's not doing hydraulic fracturing, but it's that doing electric fracturing. You can develop reservoirs in different ways. So closed loop versus open loop for me, I'm, as you know, more interested in, is it existing oil and gas technology or is it new technology? Because that is a huge driver of risk and cost and market readiness and so forth. So I think I would just open loop or sort of closed loop drilled reservoirs, predominantly, they're great in every other way, except that they're very expensive to drill. to drill quite a lot in order to get the performance you want. So as drilling costs come down, they become more and more competitive. And so time is on their side, interestingly, even if today it's pretty easily to get to an open loop techno-economically and decide that that's the best solution. But I think we also have to remember that closed loop has some other advantages. You can do it anywhere. You don't need a particular rock type that fractures in a certain way. You don't need to, have that, a regulatory permit to be able to fracture however you do it. You could potentially run other working fluids through the system. Ingrid, you had that on there on your slides as well, that it doesn't all have to be water. If you have a closed system, you could do something that's more efficient at heat transfer or taking up heat per mass. So, you don't have water losses. There's a lot of benefits by closed loops that I think maybe, I mentioned XGS before as an example of a company that's doing essentially closed loop. It's just a single well closed loop. And I think we're in the infancy of this industry. We're going to see some really cool designs that we haven't thought of today. And I'm really looking forward to that journey as we go.
And that's where I think, just building on what Torsten and Ingrid said, I really think that's where this sector becomes so interesting. Just the number of technologies and trials that are coming out. In a way, I'm glad there's not a single solution that's ready to modularize today, because I don't think we've quite cracked the nut on it. And I think the more that companies, and I think Ben, maybe you said it a little bit early about some, spiciness between some of the different technologies. But I think the more that we can cross-pollinate across the learnings across these, I think the better that of an outcome that we're going to have, and not even just amongst the geothermal technology sectors, but especially when it comes to super deep hot that Torsten, you're really interested in. When you look at whether it's space or deep sea, there's a huge amount of technology overlap when you look at the pressure and temperature regimes there. And so I think where and how we can find ways to share or get people to connect in this, I think there's going to be some great ideas and some great companies coming out of it.
Excellent. So there's one slide you shared, Torsten, which made me think about one question I wanted to ask, and which I saw popping in the chat as well. You had the funding versus funding deployed versus what needs to happen, and clearly a lot of money is going into tech-enabled project developers, as you show. And one question we've been wondering is, where will the value accrue in that sector, basically, so that it makes sense for founders and investors to focus on? And you could obviously categorize it broadly into project development, tech supplier, and maybe like some kind of vertical integration. It's oversimplified, but that's one way to put it. Do all of these three categories make sense from a founder perspective and venture point of view, or will value go mostly in one of these categories? And is it maybe a dynamic question? It will evolve over time, maybe.
Yeah, that's it's very hard to make a quick answer to that. I think it's actually not a bad thing that most of the money is going to developers, because that is really a sign that this market is getting ready for commercial, the real world, you know. So that it's more of a matter of I'd like to see more money for technology, but it's actually great that company like Fervo and Ever and many others are able to raise money for what they're doing. Now, the reason why it's a hard question to answer is that if we are correct with IEA's projections of where this market is going, if we are correct that the cost, the LCOE and the cost of the systems and CAPEX is coming down sufficiently, this market is going to be very, very large. And for that reason, you are absolutely very wise to go into any of those types of, whether you take a developer today, you take a technology company today, all of them will be symbiotic essentially and probably end up doing fairly well. Now, if we are not right, all of them will suffer because, you know, the developers might have a hard time getting further funding, but the tech companies like what we invested in won't have anyone to sell to. You know, there's going to be no customers. So in some sense, there is a market risk that over time will become more clear. And it's hard for me to say that necessarily developers are better investments than tech. We have chosen the path of tech companies. And as I said, the picks and shovels, that's our choice. We think we can do a lot with those companies, but that does not mean it's a bad idea to invest in Fervo or anything else. Quite the opposite, I'd say.
Yeah, I wish I invested in Fervo in the early days when they started, because they're doing very well today.
Absolutely.
Ingrid, what do you think, like on the geothermal heat point of view also? Because there's also like the same question for power, but for heat.
So I think in terms of geothermal heat, you have, I don't want to say mature, but maturer industry when it comes to the ground source heat pumps for buildings. That's where how most of the geothermal heat has been provided recently. And you see there, you tend to have tech-enabled developers, right? So they have their own tech, but they also come and provide you with the entire project development, and they install and they put everything together. So I think it's a bit tricky because you develop your tech, but you want someone to use that tech as well. And if you don't have enough developers, then how do you de-risk and prove your tech? So you kind of end up in this vicious cycle as well, where you end up having to be the developer of your own tech. But I think, like Torsten said, as the industry grows and matures, and I think that's the same for both heat and power, more tech developers can be tech developers that then license their technology out to developers. Sorry, that was many uses of the word developer, but essentially you can be someone who has the tech and that's it, and that can be great, but you need to have enough project developers who will end up using your tech. And I think that's what's missing at the moment, especially when we're going into, for example, industrial heat from geothermal.
Super cool. Super cool. Becky, I have maybe a question for you. I think we're almost at the end of the hour. There's a big piece of your report which is around transfers from the oil and gas industry, and even in your model you have a high level of transfer and low level of transfer. I'd love to get a more granular view from you on what could happen on the higher level of transfer. So what are the kind of technologies and know-hows and things we could better transfer from oil and gas to geothermal, in your opinion?
Thanks, Ben. It's a great question. Part of it we've talked about to a large degree, right? Because it's the nuts and bolts of the oil and gas industry. And I I do want to caution that there is a lot that the geothermal industry, especially on the surface side of that, that actually oil and gas could probably learn from as well. But when it comes to oil and gas transfer of learnings, it really becomes down to the nuts and bolts of drilling and completing these wells. On the EGS side, for example, it's really taking a deeper look into how we can actually fracture and communicate. There's two ends of this that we haven't really talked about. Part of this is that how do we go about really exploring for these and assessing geothermal resources. So when it comes to understanding the amount of heat that an area might be able to hold, and also the amount of heat that it might be able to transfer, we haven't really, let's say, cracked the nut on that one yet. And I think there's a lot that the oil and gas industry can bring to bear. Part of that is technical, but part of it is also taking across the, let's say, the reserves resource classification schemes that the industry has built up. And that, for example, whether it's a system called PRMS or the work that the SEC has done with the Society of Petroleum Engineers, it's established a way for the community to communicate from what does the subsurface look like and how do we communicate that to the financial community, to banks or others that are looking to invest. So it's not necessarily like a super interesting technology transfer. It's a transfer of how we actually communicate and get more funding in. On the opposite side of that, it really comes down to production systems. So how do we actually better understand what we're producing and how to tweak that and how to do that even faster? So a lot of using artificial learning or machine learning to understand what are the small system changes that are indicating that something's going wrong, so we can go ahead and catch those things and improve them before we actually end up going down with the well or with the system for itself. And can I build on that really briefly?
Please.
There's something I wanted to actually go back and add to what Ingrid and Torsten were saying earlier that I thought was super cool, and it links back to what Torsten was showing in his initial presentation. And it goes back to the number of investors and the type of investors that are in the community today compared to what we had, say, after in Clean Tech 1.0. There's an MIT paper that I do really like that looks at venture capital and clean tech from 2008 to 2016. And one of the key learnings from that was that venture capital is kind of trying to do everything on its own. And I think it's different this time because you're seeing debt come in. You're seeing you're seeing that project development starting to come in. And so for me, that's a really encouraging sign. But the one thing we don't have is we don't have still a really strong demand pull necessarily and have that across many different countries, right? So it does seem to be very, very localized in the US and also with some pulls from, say, data centers and others. So sorry, Ben, I'm going to hand that back over to you, but I wanted to jump in on that before we
that was great, Becky. Thanks. Great answer. And yeah, and we're also very interested in hearing from people who want to transfer also from oil and gas to geothermal, because we think there's a lot of great expertise in that industry that could be better applied to building massive geothermal companies. So we can't wait to hear about these folks. We are at time, and to be honest, looking at all the questions we still have in the chat and also like everything we could discuss, we could easily do a 2-hour webinar on this and even more, but it would be maybe a bit too much. So we're going to wrap things here. Maybe as a last quick word, Becky, Torsten, Ingrid, do you want to say a word about who you would like to hear from the audience who's watching that, and why should they reach out to you?
Yeah, I can go first. I think we have to remember that when this is happening, we are going to be building thousands of power plants and tens of thousands, not hundreds of thousands of wells. So this is a very, very large industrial operation. And I think this is why we need to see people all sorts of disciplines. Yes, oil and gas experience is really useful, but a whole bunch of other areas of expertise will be necessary for us to scale this up. And as venture capitalists, we're interested in the full value chain, the full stack here. So don't be shy. Tell us that scaling story, and yeah, happy to talk.
Go ahead, Rebecca. I'll go after.
Sure, thanks, Ingrid. And again, it's a great question, Ben. I would say just reach out to us, period. One of the things we haven't really talked a lot about is the social acceptance side of this. And so when we talk about learnings transfer from the oil and gas industry, and I've seen so many just extremely talented people move across into the industry. One thing that we don't necessarily want to carry across is the negative connotations with the oil and gas industry. And so I think there's I think a good bit of thinking to do and some work to do on why or how geothermal is different, or what steps do we need to take to help make sure that that it is different.
That's a great one. We had one experiment in the east of France in Alsace where they had some seismicity issue and it kind of set back the field for a few years. So we don't want to have that. Make sure we don't repeat that. So yes, totally agree. It's important. Great. And last but not least, Ingrid, who do you want to hear from?
Perfect. Yeah, I'll be super quick. I think we've highlighted throughout this webinar that the innovation gaps are still there. There's a lot to solve for. So anyone who's interested in solving these problems, please reach out because there's a lot that we still need to do to really harness the potential of geothermal.
All right. Thanks a lot to the three of you. It was really fun to host this conversation. I really enjoyed this session. Thanks to everyone who joined today. And we'll send an email recap with the recording and so on. So looking forward to follow up with all of you. Have a great rest of the day. And until next time.
Thanks, guys.
Thank you.